Hello everyone, I'm Swati from Bright Scholar Senior Secondary School. Today we are going to talk about another chapter, that is electricity, chapter number 12. So I'm sure you all know about the basic elements of an electric circuit. Let's say a bulb and its symbol, a cell or a battery and their symbols and the difference between them, switch on and switch off, their symbols, the symbol of a wire, and how they are connected together to make a complete circuit. So in this chapter, we are going to cover following topics: electric charge, what is electric charge, what is electric circuit, what is electric current, what is potential difference, what is Ohm's law, this is something new for you all, what is resistance and its dependence on different factors, what is the heating effect of current, its advantages and disadvantages also we are going to talk about, and finally we are going to talk about electric power. Very first, we are going to talk about what is charge. We are going to find out what is charge and how it came into notice. That means how it was identified, how it was discovered, who identified it first. So the picture on the right says it clear that if the charges are positive, if both the charges are positive, they do not come near to each other. That means they repel. If both the charges are negative, they also do not come near to each other. That means they also repel. But if one of the charge is positive and another one is negative, they attract each other. So this is something you have already studied in grade 7, in grade 8, and in ninth also. So we are going to talk about these topics in elaborated form. What happens when glass rod is rubbed with silk? So basically, when we rub both of them together, glass rod loses some of its electrons, which is grabbed by silk, and once this rubbing is over, the glass becomes positively charged and silk becomes negatively charged. So as you can see in the picture on the right, when these two are rubbed together, the glass acquires positive charge and silk acquires negative charge. So the question is that how this transfer of electrons occur and why glass acquires positive charge. So if you remember in grade 9 we have dealt with chapter number 3 and 4 where we studied that an atom consists of protons, electrons and neutrons. Here we are going to talk about protons and electrons. So as we have studied that number of protons are equal to number of electrons, that means the positive charge is equal to negative charge. So the same concept is going to be here. When we try to rub the glass rod with silk, glass starts losing its electrons. That means glass starts losing its negative charge. And this negative charge is taken in the form of electrons by silk. So that means negative charge is reducing from glass and is increasing in silk, but positive charge is more in glass now and is less in silk. So this results in positively charged glass and negatively charged silk. So what is the conclusion here? That due to this concept of friction, what is friction? That it's a force which tries to resist the motion, which tries to resist the movement. The charges, the concept of charges came into the picture and it was first identified and discovered by Coulomb. Okay, so now the question is, what is an electric charge? So electric charge is basically the amount of energy, you can say, or the amount of electrons that passes from one body to another. In simple terms, the amount of electrons which is getting transferred from one body to another. Now, how this transferring of electrons occurs? In the previous slide, we transferred the electrons when we rubbed the glass rod with silk. So there are different modes by which this transfer of electrons can occur. It can happen by conduction, it can happen by induction. Okay, so now there are two types of charges. The very first is positive charge and second is negative charge. And this charge is symbolized, is denoted by Q, capital Q. There is small q also, by which we try to denote charge. We are going to find out the difference between the two later on. And its unit is Coulomb, as it was first discovered, or you can say identified by Coulomb. So that is why its unit is also Coulomb, and we write it as C. Okay. So as you can see in the picture, that there are number of electrons which are equal to number of protons. So as electrons are lost and are gained by the another object B, this acquires positive charge, or you can say positive charge dominates the body, the object A, and here in object B, negative charge dominates. So another question is, what is an electric field? So electric field we will try to understand by recalling one activity we all have done when we were quite young. If you remember, you used to try to pick the bits of paper by a charged comb. By rubbing the comb in your hair, then you used to try to pick the bits of paper. So you can feel that there is an energy lying between the comb and the bits of paper. Now that energy, just recall that energy, recall that effect, and then come here back. So now I'm going to tell you what is an electric field. When these electric charges are kept together, they create a small area around them where the effect of this charge can be felt, and this effect is called electric field. How we can draw them? You simply need to write the charge, and drawing the lines around it makes the electric field lines. So if these lines are way too closer to each other, it makes the field strong. Just like in this picture, as you can see, there are more number of lines and they are closely spaced, so it becomes stronger field. If there is a good space between the lines, it becomes a weak field. As it is quite evident from the picture that like charges repel each other and opposite charges or unlike charges, they attract each other. This is positive positive and negative negative, they repel each other, and the positive and negative charge, they attract each other. So now we will talk about what is the quantity of charge. So basically, quantity of charge is the number of electrons contained by it. So as you can see in the left side, Q is equal to Ne, where Q is the total charge, N is the number of electrons or protons. Basically, we talk about electrons here and not protons, but also because electrons, the number of electrons are equal to protons, we can write here as number of electrons or number of protons. And E is equals to charge of one electron, or you can say one proton. So the calculated value that comes around is 6.25 into 10 to the power 18 electrons. That means 1 coulomb of charge, it is equal to how many electrons? 6.25 into 10 to the power 18 electrons. That means what is the charge on a single electron? Now the question is, what is the charge on a single electron? The charge on a single electron, on one electron, is equal to 1.6 into 10 to the power minus 19. I think it's clear. So how we came to this value, how we have calculated this, let's find out in the coming slides. This is an important question, keeping in mind board examinations. So as we have studied in the previous slide, Q is the total charge, N is the number of electrons or protons, and E is the charge of one electron or proton. So there is one example here. Let's find out that this much of the electrons, 1.25 into 10 to the power 19 electrons, are added into an object. So by the time we read this much, it should come into our mind that this is the value of N. Then it is asking find the net charge of the object. That means it is asking for Q of the coulomb. So charge of one electron, it's given 1.6 into 10 to the power minus 19. This is the value of E. It's a very simple question. You simply need to put all the values in the formula given, that is Q is equals to NE, and it comes around, this is equal to 2 coulomb of charge minus 2 coulomb. I think it's clear. So we are writing here minus because we are talking about electron, that is why. This is one question which is given in your NCERT also, that how many electrons are in 1 coulomb. Probably this is a question number 3 of first NCERT in text question set. So here how many electrons are there in 1 coulomb? That means you have to find out N, and 1 coulomb is the charge given. That means E is equals to minus 1.6 into 10 to the power minus 19 as we know, and Q is equals to NE is the formula we know. What we have to find out, how many electrons, number of electrons. That means we have to find out N here. E is given, Q we have. So N is equals to Q upon E. That becomes 1 upon 1.6 into 10 to the power minus 19. That is approximately equal to 6.25 into 10 to the power 18 electrons. If you remember, in the previous slide we studied that 1 coulomb of charge is equal to 6.25 into 10 to the power 18 electrons, and this is how we have calculated the formula. This is how we have calculated this estimate. Okay. Now let's talk about what are the 3 types of substances we need to study when we study electricity. We have conductors, we have insulators, and we have semiconductors also. So we probably know a lot about conductors, insulators, and semiconductors. Let us revise what we know about it. So conductors have generally low resistance. What is the meaning of resistance? Resist means they cannot be against something. Resist, I am resisting something, I am trying to stop something, I am trying to be against of something. So conductors have low resistance, which allows electrical current flow. That means conductors are not able to resist the current, the electrical current flow. Okay, that means they have low resistance. For example, we have copper, silver, gold, aluminium, and nickel, and many more. When we talk about insulators, they have high resistance. So this is pretty clear from the fact that insulators do not allow the flow of electrical current. That means they resist electrical current flow. That is why they are highly resistant. For example, glass, ceramics, plastics, and wood, and there are many other examples. Now, semiconductors are those electronic materials that can allow or that can suppress electrical current flow. It depends on the need of the electronic instrument. So for that we use carbon, silicon, and germanium. Okay. Let's start with another topic, that is electrostatic potential. So what is the meaning of electrostatic potential? Let's have it from the diagram on the right side. As you can see in this picture, that it is the work done by moving a charge from infinity to other point. This is equal to the electric potential. So that means whatever work is done for bringing a charge from infinity to another point is called the electric potential. I hope it's clear. I'm repeating myself. It's the work done by moving a charge particle, let's say from infinity to other point, is equal to the electric potential. So as you can see here in the left side, electric potential definition we have already studied, and it's the work done for moving a charge from infinity to some other point. So its unit is joules per coulomb. So how can we give it a formula? As we are saying that it's the work done, that means W upon work done in moving a charge, that means work done upon charge, that means W upon Q. It is equal to V. Okay, V is the symbol for electrostatic potential. So this electrostatic potential is measured by a voltmeter. and its unit is joule per coulomb. So electric potential can be positive and it can be negative. It depends on the body. If the charge on the body is positive, electric potential becomes positive. If the charge on a body is negative, electric potential becomes negative. Electric potential is a scalar quantity and it can be added algebraically. That means, for example, for one system we have electric potential -3 and for another system we have electric potential 5. So what is going to be the total electric potential? -3 plus 5. That is equals to, that becomes 2. Okay. So voltmeter, it is electric potential is measured by a voltmeter, and voltmeter is always connected in parallel with a circuit. So what is the meaning of this parallel? We will find out in the upcoming slides. Generally, in a circuit, there are two types of connections. One is series connection and one is parallel connection. So we will find out it later on, but this is very important question. Generally, it comes in board examinations, that how is voltmeter connected in a electrical circuit? How is ammeter connected in a electrical circuit? So as you remember, that I am sure you have studied about ammeter, which is connected in series, which measures current, and it is always connected in series with the electrical circuit. But voltmeter, it is connected in a circuit, and that too parallel in manner, and it is always found that way, and it is helpful in measuring the potential difference. Okay. So what is potential difference? Potential difference is the amount of work done in bringing a unit positive charge from one point to another point. That means the movement is happening of the charge, and the work is being done for moving the charge from one point to another point, and this is entirely done in an electric field. Potential difference, it's a scalar quantity. It is joules per coulomb, or you can say volts, 5 volts, 6 volts. I'm sure you would have seen it's somewhere written like 5 volts, 6 volts. So what does that mean? It means it's electric potential. It's the potential difference. That is, the SI unit is joules per coulomb. So this is responsible for the flow of current in a conductor. That means how, if the question comes, how is current flowing in an electrical circuit, in a conductor? Who is responsible for it? The thing that is, the phenomena that is responsible is potential difference that is being generated in a system, and that is how the current flows, and this is measured with the help of a voltmeter. Now it's a very important picture. So this is the infinity point we were talking about. Now from this infinity point, the charge is brought to a point A, let's say. So work is done from bringing a charge from infinity to point A. In another case, the same charge is taken from infinity to another point, that is B. So there are 2 points here, A and B. Now whatever the difference lies, electrical potential difference between A and B, is the potential difference. So now the question comes, what is electric current? Electric current is the direction of flow of current. Okay, so what is the definition for it? An electric current is the rate of flow of electric charges in a circuit. That means the rate by which the electric charge flows in a circuit constitutes electric current, and it is basically the direction of flow of current. And how it is measured? It is always measured in amperes, that is capital A, and it is measured by ammeter, which is always connected in series with the circuit. So here this picture is very important, the bottom of the left side. Now for example, this is the circuit, and I'm sure you all know that this is a positive terminal and this is a negative terminal. So we are saying that this is this direction. This is how the positive charge is flowing, and this is how the positive charge is flowing. As it's mentioned here, it's the flow of positive charge. So that means the direction in which positive charge is flowing, it will be opposite of the direction in which electrons are flowing. So they are the opposite direction. If left to right, for example, for instance, if left to right the positive charge is flowing, that means right to left what is flowing? The flow of electrons is there. Okay. So this is, I think, clear that we have talked about the charge, we have talked about voltmeter, ammeter, and electric potential and potential difference also. Here we are talking about electric current, which we are defining as the time taken in the flow of electric charges in a circuit constitutes the electric current, which is measured in amperes, and it is measured by the instrument called ammeter. And in a circuit, the flow of positive charge is always opposite in direction of the flow of electrons. So the unit of measure for current is the ampere, which has the symbol A, as we studied in the previous slide, and it is measured by a device which is called as ammeter. This is the device here, you can see in the picture. This is available in school's physics lab. When after the lockdown, when we'll be coming to school, I'll show you how it looks like and how it works. So this is an important question here, that when measuring the current through component, the ammeter is always connected in a series in the same loop with that component. So as you can see in this circuit, that this ammeter is connected in series with the system. So there are two questions here which you need to memorize properly, that how is ammeter connected in a circuit and how is voltmeter connected in a circuit. Ammeter is always connected in series with the circuit and it is used for measuring current, but voltmeter is always connected in parallel with the circuit and it measures the potential difference. So now I'm giving you two questions that you have to work upon. One is, how can we get continuous flow of current in a circuit? For example, there is a circuit with me and I want the current to flow continuously. How can I arrange such a system? Second question is, you have to find out that how much energy is to be given to each coulomb of charge which passes through a 6-volt battery. Think about these two questions. Try finding out their answers. Solve them in your notebook. So thank you for watching. In my upcoming videos, we will talk about the further topics of the chapter. That is, we will find out what is series connection, what is parallel connection, what is Ohm's law, and many more other topics of the chapter. Stay blessed, stay safe.